And so then you come to this notion of what is referred to as the modified sit and reach test, which is from Hoger and colleagues. And the aim of this really was to countenance a lot of the issues that we saw with Wells and Dillion's version, and also that we saw with Patterson's backsaver test, neither of which have any standardization, no standard set 0 point for the participant to work from. So in this version, it's designed to take into account limb lengths and the advantages it's offered in the original sit and reach test if you've got longer arms. If I've got long arms, I've got a natural advantage because I can just lean forward, I can just stretch using my arms. So this is designed to take that out of play. And it's quite simple. You sit the participants against a flat wall, and what you do is you get them to sit with their arms out extended like you see this chap is doing here. That now becomes his 0 point. Irrespective of anything else, that is now the 0 point. You now measure linear displacement from that position. So it means that we've got a standardized test. So that increases the validity and it reduces some of the variability that we saw both with Wells and Dillion's version and we saw with Patterson's version, and also that we saw with the chair saver, I suppose, to a certain degree. But it doesn't countenance any of the other issues. We still don't know what's driving the range of motion in this individual. We still only have a linear displacement. We don't have an actual angular displacement measurement. But it at least provides some degree of standardization. Now, if we take this, which is from Hui and colleagues, they've written this. Hoger suggested that the classic sit and reach test does not control for possible limb length biases. Therefore, they propose a modified version of the sit and reach test that takes the difference between the final position of the reach and the initial position, they call it the difference score, when the participant sits with the back straight and vertical to the floor. That is a relatively zero point is established for this modified sit and reach test. That seems to be a very logical idea, and it absolutely increases the validity. But you still cannot countenance all those other variables, all those other factors that we've referred to that have ramifications in terms of actually how valid are any of these tests in assessing range of motion. And here you can just see this kind of setup that we're talking about. So they're measuring this kind of distance, they're flat against the wall, this is the start point. Notice now, remember in the traditional Wells and Dillion and the modified, this distance was 23 centimetres. It's not 23 centimetres because we're trying to standardise this start point here. So now we simply measure the distance from this point to the point of maximum stretch. And that becomes their, in essence, their measurement of range of motion. So again, as I say, there isn't an awful lot of data. This is from Patterson's group. I just wanted to show you this a little bit because you can just kind of see, here's the modified score for males, modified score for females. And it's worth noting, that they are fairly similar. They're actually fairly standard scores in terms of what you would see for a general population in a conventional sit and reach test. And in fact, if we go back and we look at this data set here, and we've got kind of our traditional sit and reach scores, and here we go, 23 to 28 centimetres. It's a pretty similar in terms of what we're seeing to a conventional sit and reach test. Now, how do these all compare? So what we've got here is we've got a data set which was published in the British Journal of Sports Medicine. It's a while back, over 20 years ago. But it's actually quite a compelling data set because what they've taken for us is they've taken for us a chair test, which is the CSR, chair sit and reach. We've got our standard sit and reach test, which is SR. And then we've got our back saver, which is the BSS. And then you've got it for right and you've got it for left. And then we've got goniometric measurements. Don't worry about goniometric measurements for the moment. I just want you to look at these. So this is kind of, are they associated? It's not, are they different? Are they associated? I'm asking the question in a slightly different way. And so what we can see is if we take the chair saver test, chair saver right is correlated to chair saver left. Okay, most people have fairly similar degrees of range of motion on the left and right leg, unless they've got an injury. If we now go and we take our chair saver right, if we take our sit and reach and we compare it now to chair saver left, you'll see that it has a correlation of 0.23. It's marginally correlated, but the same correlation exists to left and right. If we now take the back saver test, it is not correlated to the chair saver, it is not correlated to the left or the right, but it has a mild correlation of 0.45 to the traditional sit and reach test. So it's interesting that the chair saver, despite the fact the chair saver in essence is a linear displacement, it doesn't seem to correlate to a similar linear displacement using the back saver test. If we then go to back saver right, same thing we saw for left against the chair, but similar correlations to the sit and reach test, fairly similar. But look, the correlation from left to right is also not particularly high, certainly not what we saw with the chair saver test. So it does suggest that there is variability in these tests, and it's almost certainly because of the differences in the approach taken with that back saver test, which is allowing for that relaxation, particularly in the lumbar region. So you then have to question, you can't compare a back saver score to a sit and reach score, to a chair saver, to a modified score. So you have to be very, very careful about how you interchange the outcomes from these measurements. So this is data from our laboratory, and what we've got here, these are our limits of agreement, and this is for sit and reach, which is in our top group, and then the modified sit and reach, which is in the bottom group. And remember that the key with limits of agreement is that it's fundamentally not only looking at the bias score, which is our middle line here, but it's looking at the 95% confidence intervals and looking for the spread of that data. So this represents, box 1 is comparing trial 1 to trial 2, this is trial 2 to trial 3, and this is trial 1 to trial 3. So if we look at this data, what you can see is when we do trial 1 to trial 2, it looks like in sit and reach test there's a plus or minus here of around about 7.5 to 8 centimeters. It's quite wide. When we go to trial 2 to trial 3, we go from about 5.5 to actually around about 2.5. So fairly similar, about an 8 centimeters. So actually there isn't much improvement across 3 trials. And when we compare trial 1 to trial 3, you can see it's actually 12 centimeters, enormous difference. So it's telling us that you probably need a minimum, in this example, of 3 trials, and probably need more than 3 trials in order to get good repeatability. Now if we look at the modified data set, here we've got trial 1 to trial 2, and actually the thing that's interesting is here's the confidence intervals. Most of the data is sitting outside the confidence intervals. It's not good repeatability. The same for 2 to 3, the same for 1 to 3. So despite the fact the confidence intervals reduce, the data is very, very widely spread. So actually, one would argue that despite the fact the modified test would appear to be more valid, it seems to actually throw up more variability in the data than a traditional sit and reach test. And that may be because people are more used to doing a traditional sit and reach test. So it might imply you're going to need more than 3 trials to get reliable data using a modified sit and reach test in a novice population group as we used here.